Hello, General Chemistry. We have discussed the rules for writing the names and formulas of simple ionic compounds, but not all ionic compounds are simple. This video will discuss transition metals and the naming and formula for ionic compounds that involve transition metals. Now, transition metals are a little bit weird. Unlike the other areas of the periodic table, we cannot look at the periodic table to find out the charge of a ion made by a transition metal. And that is because they do some weird things with their valence electrons. They do not have a set pattern like the other elements do. They can sometimes make multiple positive charges. So you could have one element, let's say iron, that could have a positive 2 charge, or it could have a positive 3 charge. You can't tell by looking which one it is. So how do we deal with this? Well, we have to change the way we write their names to help communicate what their charge will be. And that involves Roman numerals. So let's take a look. Our first question that we're going to deal with is, what is the formula of cobalt nitride? And you'll notice that cobalt is a transition metal. Nitride is a regular anion made from a nonmetal. But in the name, we include this information. And this always comes after the cation. This, in parentheses, is a Roman numeral. So our Roman numerals can be 1, 2, 3, 4, 5, 6, 7, 8. Now, we will never use any Roman numerals other than this because there are 8 valence electrons, so we're unlikely that we'll even ever use 8. But these are the Roman numerals that we're going to use. So it reads cobalt 2 nitride. That is the name of the compound, cobalt 2 nitride. So how do we write the formula? Well, the steps for writing the formula start out to be the same. You have to first find the symbols. So what is the symbol for cobalt? It's CO. Now, what is the symbol for nitride? Well, there is no nitride, but we know that ions change to the IDE ending. So if we look at our nonmetals, we find nitrogen. So that nitride is the nitrogen after it's been changed to its IDE ending. So we need the symbol for nitrogen, which is N. Well, we've got our symbols. Now we need our charges. When we're writing formulas, we find the symbols and then we find the charges. Well, nitrogen we can look up on the periodic table. Nitrogen has 1, 2, 3, 4, 5 valence electrons. It's got 5 valence electrons. We know that it is a nonmetal with a high electronegativity. That means it is going to gain electrons. So it has 5, and it's going to keep gaining until it has a full valence shell. That means it's going to get to 6, not full, 7, not full, 8. Now it's full. So it had to gain 3 electrons. If it gains 3 electrons, it's going to have a -3 charge. So we can write that in. Nitrogen is going to have a -3 charge. Great. Now, cobalt. We can't do that trick with cobalt. We can't look on the periodic table and say, oh, it has this many valence electrons, so it's going to do this thing. Can't do it. But, luckily, we can look at the name right here. That Roman numeral, that tells us, that always matches the charge on the cobalt. So it's going to be cobalt plus 2, because cobalt is a metal, so it has a low electronegativity, so it will lose electrons. So it's going to have a positive charge, and that charge is going to be 2, because that's what's in the Roman numerals. So, cobalt plus 2. Great. Well, now that we're here, we need to balance them. We need to make them neutral. So if nitrogen is -3, that means we're going to need more cobalt because cobalt is behind. So we're going to add a plus 2. Oh, we're going to add a plus. No, what is happening? A plus 2 there. So now we have +4 on the positive side and -3 on the negative side. So we're going to need more. We're going to need more negative. So we're going to need another nitrogen. And now we have +4 on this side and -6 on the negative side. So we're going to need more positive to balance it out. Okay, now we have +6 on this side, and we have -6 on this side, so that equals 0. So we're neutral. How many did we have? Well, we had 3. 1, 2, 3 cobalt. What is that? Oh yeah, that's right. I'm sorry. We have 3 cobalt, but we only had 2 nitrogen. 1, 2. So our counts are 3 cobalt, 2 nitrogen. CO3 in 2. So there you have it. This is if this is the name, cobalt 2 nitride, then our formula is going to be CO3 in 2. And we had to do that by balancing the charges, and to do that we had to find the charges, which for the transition metal comes from the Roman numerals in the parentheses. Now let's go to a different problem. Here we go. What is the name of this guy? BIF3. Well, we kind of have to go backwards. If it's Bi, we got to find that. So if we look that up, we will find that number 83, element 83, Bi is a bismuth. And the cation comes first, so we're going to write bismuth first. Bismuth. And F, well, we know that that's going to be our anion. F is fluorine, but we know we change it to its IDE ending, so we're going to say bismuth fluoride. There we go. We are not done. Because bismuth is a transition metal, we have to put its charge in parentheses here. So to do this, we have to figure out its charge, which means we have to go back to the formula. So bismuth has some charge, and we don't know what it is. But fluorine has a charge, and we can look that up. Fluorine has 7 valence electrons. It has a high electronegativity, so it's going to gain electrons. So if it has 7, it's going to gain until it has a full shell. It can gain 1 more. It has 8. That's a full shell, so it can only gain 1, so its charge has to be -1. Now let's go back to the count. We know that there are 3 fluorine here, so we know that overall we're going to have 3 of these guys involved. So what does that mean? Well, that means this side of this compound is going to have a -3. That's what it means. Well, for the -3 to be balanced, we have to have a +3 on this side. So this +3 has to come from our bismuth. So that's going to end up being a +3. So the only way this can be neutral, the only way bismuth can cancel out and become neutral with the 3 fluorines is if it has a +3 charge to cancel out with each of their -1s, which means that our compound is bismuth 3 fluoride. So if this is our formula, this is the name of our compound. You have to go backwards. You still need, once you have the symbols, you got to find the charges, you got to balance the charges, and whatever you need to balance, that's what the charge of the cation is, so that's what goes in the parentheses, bismuth 3 fluoride. These have been the rules for writing the names and formulas for ionic compounds with transition metals. I hope this helps. Struggle well.